You know that feeling, right? When you're using a website, maybe an app, and it just works. It feels smooth.
Mm.
Even if millions of people are using it, streaming, buying things, it's still fast, instantly responsive.
Yeah, it's seamless.
We kind of take it for granted, don't we? But like, have you ever really stopped to wonder what's going on behind the curtain, all that invisible work making it happen?
It's easy to forget.
Well, today we're doing a deep dive into a really key piece of that puzzle, NGINX, pronounced NGINX.
Right.
It's this powerful software, often totally unseen, but it plays such a fundamental role in how the internet actually delivers those fast, reliable, secure experiences we all just expect now.
It's got quite a history, actually. NGINX started way back in 2004. Igor Sissoev created it.
Oh, wow. Okay.
And the main goal initially was solving what they called the C10K problem.
C10K.
Yeah, basically how to handle 10,000 connections at the same time efficiently on one server, which was a huge deal back then. But what's really fascinating is how it grew. It went way beyond just being a web server. It's become this incredibly versatile tool, a reverse proxy load balancer, even an API gateway. Really indispensable now.
Okay, so that's our mission today then. Let's dig into the sources you brought and figure out why. Why has NGINX become so essential for, well, everything online, especially now with microservices and all that complexity?
Exactly.
So, to kick us off, if we strip it right back, what is NGINX at its core, fundamentally?
Right. So at its heart, NGINX is high-performance, open-source web server software.
Mm-hmm.
But its design principles are what really make it special.
Right.
First, it has this remarkable lightweight architecture. It sips resources, very minimal footprint.
Efficient.
Very. But the killer feature is its asynchronous event-driven design.
Ah, okay. What does that mean in practice?
Think of it like a super efficient waiter in a busy restaurant. They don't just take one order, wait for it to cook, then take the
Or
next.
they'd get overwhelmed.
Exactly.
Yeah.
NGINX takes a request, kicks off the work, and immediately goes to handle the next request without waiting. This lets it handle thousands, even millions of connections concurrently without getting bogged down.
That makes sense.
And that was a huge shift from, say, traditional servers like Apache back in the day,
Yeah.
especially when traffic really spiked. They could struggle.
That analogy really helps. So it juggles all those requests super efficiently. It started as a web server, but you said its versatility is key. How did it grow beyond just like serving up HTML pages?
Well, initially, yeah, its strength was serving static content, directly HTML, CSS, images, that sort of thing.
Yeah.
Fast.
The basic.
The basics, but it also quickly became really good at proxying dynamic content.
Hmm.
So it acts as an intermediary.
Okay.
It takes requests and passes them smartly to application servers running things like Node.js,
Yeah.
Python, Java,
Yeah.
whatever is generating the dynamic part of the page.
Gotcha. So it directs traffic internally.
Precisely. And then it added more capabilities to boost performance and security. Things like caching storing, frequently accessed stuff so it doesn't have to fetch it every single time,
Speeds things up.
massively.
Yeah.
And compression to shrink data size, save bandwidth, and also SSLTLS termination.
Yeah, the encryption part.
Right. NGINX handling the heavy lifting of encrypting and decrypting secure connections. That frees up the backend applications to just focus on their main job, their business logic.
That's clever, taking the load off. And it's adaptable too, right? I mean, it's configuration, the ecosystem around it.
Hugely adaptable.
Yeah.
Its modular configuration is pretty straightforward once you get the hang of it. And yeah, the ecosystem, including the commercial version NGINX Plus, means it can scale basically infinitely, from a tiny personal blog up to, the massive distributed systems powering global services.
Okay, I think we've got a good handle on what it is and the core mechanics. So the big question then, why? Why did NGINX become so incredibly popular? What are the key reasons it's now, as you said, a cornerstone for the modern web?
It really boils down to how well its features met the evolving demands of the internet. Several key advantages stand out. First, and we touched on this, is just raw high performance.
Yeah, that speed.
That event-driven architecture isn't just neat. It means it processes tons of connections using very little memory and CPU compared to older methods. This wasn't just a minor improvement. It fundamentally enabled the scale of the modern web. Think streaming, social media.
Platforms that couldn't exist without that kind of efficiency.
Exactly.
Right.
Second, and this is crucial for reliability, is its role as a reverse proxy and load balancer.
Okay, explain that a bit more.
So imagine a huge online store during a major sale. Black Friday, maybe.
Chaos.
Potential chaos, yeah. Without something like NGINX sitting in front, taking all those incoming requests and intelligently spreading them across multiple back-end servers,
Yeah.
the site would just crumble.
Overload.
NGINX prevents that. It ensures fault tolerance if one server fails, traffic goes to others, and high availability as your soda stays up. And this directly enables its fantastic scalability. You can just add more servers or containers behind NGINX, and it seamlessly spreads the load, handles growth easily.
So it's not just speed, it's making sure things stay running and can grow. What about security? That's always a huge factor online.
Absolutely critical. NGINX provides vital security layers. It can do things like rate limiting.
Starping bots or attacks?
Yeah, preventing abuse, slowing down brute force attempts, mitigating denial of service attacks. It can use IP whitelisting or blocklisting for access control. And of course, it handles that robust SSL TLS encryption we mentioned. It basically acts as a protective shield for your applications.
A bodyguard for the back end.
Kinda, yeah. Then there's its flexibility. It supports a really wide range of protocols, not just HTTP, HTTPS, but newer things like gRPC for fast inter-service communication, or WebSockets for real-time stuff.
Things needed for modern apps.
Exactly. And it integrates really well with modern tools like Kubernetes and Docker, the container orchestration platforms. And finally, believe it or not, ease of configuration is a big plus.
Really? I sometimes hear server configs can be nightmares.
Well, compared to some alternatives, NGINX uses a pretty straightforward declarative language. You state what you want the end state to be, not necessarily every step to get there. This allows for quick setups, but also really fine-grained control when you need it.
That's quite a list of strengths. Performance, reliability, scalability, security, flexibility. It covers a lot of ground.
It really does.
Now, this is where, for me, things get really interesting. The whole microservices revolution.
Ah, yes.
For anyone listening who isn't familiar, microservices architecture basically means breaking down big monolithic applications into lots of small independent services that talk to each other over APIs. It offers agility, but man, it sounds complex to manage.
It absolutely introduces complexity. You go from one big thing to potentially hundreds of tiny things,
Yeah.
all needing to communicate reliably.
So how does NGINX fit into that picture? It seems almost tailor-made for it.
It really is. In this kind of distributed environment, NGINX plays an absolutely critical central role. You've got all this complex traffic flowing between services, requests coming in from the outside. It can become a real tangle.
Spaghetti junction?
Pretty much.
Right.
NGINX steps in as the intelligent traffic director. It doesn't just route traffic, it helps tame that inherent complexity, making these distributed systems manageable and efficient. It lets developers focus on building features, not just plumbing.
Taming the chaos. I like that. So drill down for us. What are the specific key jobs NGINX takes on in a microservices setup?
Okay, one of the most common and vital roles is acting as an API gateway.
The front door.
Exactly.
Mhm.
It becomes the single entry point for all incoming API requests destined for any of your microservices. It figures out which service needs to handle which request and routes it accordingly. But it does more than just routing. It handles crucial cross-cutting concerns, things every service might need, like user authentication, authorization, rate-limiting requests to prevent overload, sometimes even transforming requests or responses.
So it takes that common workload away from the individual microservices.
Precisely. Keeps the microservices themselves lean and focused. Then, of course, there's load balancing within the microservices environment. If you have multiple instances of a single microservice running, for scaling or resilience.
You usually do.
Right. NGINX distributes the traffic evenly across those instances, whether they're containers, VMs, whatever.
Makes sense. What else?
It plays a big role in service discovery and resilience. NGINX can integrate with tools like Console, etc., or Kubernetes' own service discovery mechanisms. Meaning it can dynamically find out which instances of a service are currently running and healthy. If an instance becomes unhealthy or crashes, NGINX automatically stops sending traffic to it and routes requests only to the healthy ones.
Right.
Big boost for fault tolerance.
So it automatically handles failures? Nice.
Yeah. Its traffic management capabilities are also really powerful here. You can do advanced routing based on the path in the URL, or headers in the request, or cookies. This gives you incredibly fine-grained control. Think A/B testing, canary releases, routing specific users to new versions.
Very sophisticated control.
Definitely. And for security and monitoring, within microservices, NGINX can enforce security policies at the edge, like validating JSON Web Tokens, JWTs, for authentication. Plus, it generates detailed logs and metrics, giving you crucial observability into how your distributed system is performing.
Seeing what's going on inside that complex web.
Exactly. And one more advanced pattern, circuit breaking.
Like in an electrical circuit.
Same idea. If one microservice starts failing repeatedly, NGINX, acting as a gateway or sidecar proxy, can trip the circuit. It stops sending requests to the failing service for a while, preventing cascading failures where one service brings down others. It might return a default response or route elsewhere, protecting the overall system.
Wow, okay. That's a whole suite of functions. It
Yeah.
really does sound like it's the glue holding microservices together. So, pulling back to the big picture, why is this NGINX role so incredibly important for modern systems? What's the bottom line?
It's absolutely foundational. The bottom line, first, scalability and performance. Microservices mean lots of network calls between potentially hundreds of services. NGINX's low latency and high throughput are essential to keep that communication fast and efficient, even under heavy load. Without it, the overhead could kill performance.
Right, the communication itself becomes the bottleneck.
Exactly. Second, it leads to a simplified architecture, ironically. By acting as that central API gateway, it hides a lot of the internal complexity from the outside world and from client applications. Developers don't need to know about every single microservice, they just talk to the gateway.
Makes development easier.
Much easier. Third, resilience. We talked about load balancing, health checks, circuit breaking. All these features make the entire system much more robust and fault tolerant. Services can fail without bringing down the whole application.
Critical for uptime.
Absolutely. Then there's the flexibility with modern tools. NGINX integrates so well with things like Kubernetes, often acting as the ingress controller, the component that manages all external traffic coming into the cluster. It fits naturally into cloud-native workflows.
So it works well with how people build software today.
Perfectly. And finally, all this comes with cost efficiency. Because NGINX is so lightweight and resource efficient, you often need less hardware or smaller cloud instances compared to heavier solutions. That saves money, especially scale in microservices deployments.
Performance, simplicity, resilience, modern integration, cost. Yeah, you can really see why it's become indispensable. What an amazing evolution, really. From tackling that C10K problem to being the central orchestrator for incredibly complex systems.
It really is a testament to its solid core design and its ability to adapt.
This deep dive has definitely shown a light on just how versatile and fundamental NGINX is in today's web architectures. It's doing so much behind the scenes.
Absolutely. It remained a foundational piece. If you're building modern digital services, especially with microservices or cloud-native approaches, understanding NGINX is pretty crucial for performance, security, and just operational sanity, really.
So maybe a final thought for everyone listening. The next time you're browsing a super fast website or using an app that just feels instant, take a second. Remember that seamless experience is likely thanks, in large part, to sophisticated invisible orchestrators like NGINX working tirelessly behind the scenes. And maybe ponder this. What does that dependency imply for how we'll build the next generation of even more complex, more scalable, and more reliable systems online? What comes next?